Hello, my name is Subhash Basu, and I'm really excited to talk to you about our latest findings and the potentials to change and disrupt the area of fault simulation. What we have is a next generation regenerative AI approach for fault detection, enhanced design and accuracy and speed. Now all of this may be sounding very complicated, but actually, as I explained, it is going to turn out to be fairly a simple model. So, traditional fault simulation we continue to do as pretty much as where we were. However, the problem with the fault simulation is that, a static fault, there are several layers of faults which you need to. It's at the port level, you need to go to every single node and you have to do stuck at 0 and stuck at 1. What it means to an SoC, say with about 18 million gates or even 60 million, is a voluminous number of faults, okay, and each of them are stuck at 0 and stuck at 1. What you need is high performance computing, parallel computing, redundancies in the computing environment, and you need a lot of time, because this is going to take a lot of time. So now what we have suggested is that we use the power of AI and ML, and we reduce the number of vectors required. So the first time around we're going to do it just pretty much the same way. We're going to simulate a normal simulation and run it like using a regular simulator like BCS, Quest or Swim, or whatever simulator you like. But we will be injecting in zeros and one at every single node. This particular output vector, which will be voluminous, we will send it to our ML engine, which we will develop using 80% of these vectors. We will develop a model which will validate on the 20% of the vectors. Probably this diagram here will be giving you some kind of ideas what we are doing. Not to worry too much. 80% vectors, 20% for validating our model. Once we have a model, and if next runs, the future runs, you will find that we don't need to run 80% anymore, but we will predict the entire vector based on a 20% sample. That's the kernel of your fault simulation. So what you gain basically is you get a huge gain on time, and you also, what happens is that you don't need high performance computing, which is very important because the high performance computer is expensive and not everybody can access it also. And of course the time to market guidelines, that you can see that you're working only on 20%, so it really makes it much faster. The third important thing is you save money on expensive fault simulation tools. They are pretty expensive and you don't need to spend on it anymore. So here is an example where AI ML can help us do high performance designs, maybe for for any SoC which is 60 million, 80 million gates or whatever is required in far less. I look forward to demonstrating all of this by examples a little later. Thank you.